Introducing the Trolley Bat 4 Senior Design 2 project. Thank you, Belmont Trolley Incorporated, for sponsoring this project. And thank you to the UNC Charlotte Lee College of Engineering Senior Design Committee. Inside of the Bat Cave, which is UNC Charlotte's Battery Complexity, Autonomous Vehicle, and Electrification Research Center, the Power Cart has been developed. The Power Cart is leading the way in evolving light rail systems. By replacing overhead high voltage power lines with a compact battery powered system, we're making trolley transit cleaner, cheaper, and more efficient. Belmont Trolley Incorporated has a goal to reclaim old rail lines for their fleet of historic trolley cars. Their goal is to make public transportation more accessible by connecting their local college, Belmont Abbey, to downtown Belmont. Eventually, they hope to provide public transportation between Belmont and Charlotte using the rail lines shown. Our project focused on developing a clutch mechanism, a braking system, enhancing the electrical capacity, and a control app to allow the cart to be fully functional. When in use, the power cart is towed behind a trolley car and has resistance from the power cart's motor. To prevent that, a clutch mechanism was developed to allow the motor to engage and disengage the drivetrain. With specific geometry, the positive clutch had to be custom made. It can be actuated using a hand wheel and clamped when in the desired position. The clutch performed very well throughout testing. The emergency braking system was developed to engage in the case that the batteries die. To accomplish this, a spring is held in compression by an electromagnet until released. The system is then reset by a linear actuator. The parts created were welded to the power cart, then fully installed. After a significant amount of testing in the Batcave, the brakes were tested in the field. Unfortunately, the brakes did not meet the project specifications due to poor contact on the wheels and low holding force from the electromagnets. To increase the electrical capacity and power the high voltage trolley cars, an additional 350-volt Nissan Leaf battery was installed. The electrical system was designed to be able to discharge the two batteries in series for 700 volts while charging individually at 350 volts with the onboard charger. The user interface controls the Programmable Logic Controller, or PLC, from a web browser using ladder logic. The onboard computer has its own Wi-Fi router to allow for a user to connect to the cart. The web browser can be pulled up on a smartphone once connected in order to control the power card directly. This mobile user interface will eventually become an app for ease of use. The power cart is paving the way for battery-powered rail technology. Look out for it in Belmont, North Carolina.